I thank everyone being in attendance. The point I want to make is essentially a pricing equation that we have when we port AI from central controlling unit, like the server farm in the cloud, toward the edge, and how we define the edge. And I'm going to walk you to the fact that we could have, through AI, whether it's pre-trained or even training on local, so on device, worth around $2, $3 or even less. So essentially, well, this is a nice quote, but it's there to remind us all that we techies tend to usually sometimes make our life more complicated than it is. So technology is the best and worst thing. If we make it seamless and work effectively with people, and you must all remember that when you open some product designed by this guy, there is no instruction booklet, it just works. That's an important thing to bear in mind. Now, coming to the topic of this presentation, you all know that the edge AI is coming. Why? Because of latency. Why? Because of security, to and from the cloud. Why? Because if we want intelligent cities, if we want intelligent system, we need to delocalize the intelligence, or whatever we call intelligence, at the device level itself, because the sheer scope of the IoT will never allow a centralization. And the last argument is centralization at all costs might end up bringing us into a world we don't like, big brotherly. So essentially, these are things that all of you know. The AI chip industry is poised for growth because we're not the only one dealing with that, and people know. But when you look on the right here, you see that it's all based on smartphone and tablet and a bit of wearable and enterprise edges here. But how do we define the edge? Well, it depends on the price, the BOM price, the bill of material price. If we need for the edge to be, let's say, using neural processing unit or GPUs, we know they're costly. They're fantastic because they're being designed. Early on, NVIDIA came from the game industry, but in the end, we know that those chips and their architecture is ideally poised, ideally designed to process graphic, to process imaging, to process graph database, or to process neural net. They're fantastic, but they come at a price. Most of you knows that a GPU BOM will go around $30. So intrinsically, you limit the capability of having an edge-based device to a pricing that cannot be put inside any device, because unless you have a phone, a fridge, a car, or some high-end electronics, there is no way you can justify from a commercial perspective this pricing. And the same for NPUs, and even these days, people, they try to do graph accelerating processing, or you have a lot of companies being really and truly trying to come to the edge with better technology, but they always rely on imaging. And people forgot the good old CPU, and I'll come back to that, because they can be arrayed, they cost less, and they can be quite powerful. So that's how I reshuffle the economic equation. I hope I'm not the only one who is born in the 60s in attendance, because before a computer or a TV screen was an area of pixel that was resolved in time, with millions of pixels on the screen, we all knew that the cathode ray tube, the CRT is the cathode ray tube from physics past, where we had a single line being beamed back and forth across the screen, which had a phosphor component for lighting and or different component for color screen. But in the end, this is a vector line. So I try to make it simple, but essentially we can vectorize an image. We don't have to use graphic database. We can have good old vector, and if we shape the data set in a certain format, then we can make use of CPU and array them, and we don't yield any precision doing so, actually, and that's the topic that Aerendir has been good at. So that's what I just said. You can get a cheaper device with the same computing power, depending on your architecture, at a fraction of the price, without yielding without losing any precision. Because in biology, especially in some question that we deal with, the IoT or the edge, we don't need the double precision anyway. Who cares about 16-digit after the comma point when it's not needed. When it's needed, I'm all for it. But a lot of use cases do not request that or do not even require that. So to do this, because we're not the only one thinking about that, we had a partnership with, some of you must know Sci-Fi. They have their own architecture and tool set and IPs dealing with that based on the ARM technology, it's not ARM, it's the other. I'm sorry, based on their own technology. And we intend to create this year 3 level of device based on their computing power. And what is the impact of taking such a cheap, low-cost AI chip direction? Think about it. I just mentioned vectorization. You know, this is the technology backbone. You don't use graph representation. But then you can do static and dynamic training, as I mentioned earlier in my presentation. You can pre-train the device. A lot of companies do that, and that's the way to go. You can constrain question sometimes to situational awareness that can be pre-trained, and then you can push the code or the result of your classification on edge device. But you still have a problem of inference. If the data is complex enough, then you need a lot of sensor and you need integration. You need essentially to redo some of the math you used to classify to reach the conclusion after training. So you still need computing power there. But you can do pre-train, and if you pre-train with low-end CPU type architecture, in the end, you can go very low. And that's what we're doing in some of our pre-trained AI project, where we have a project now where we try to do age block, to recognize age based on neurophysiologic pattern, and we can do it. And the chip needed to do that is actually 2.7 cents. So it's quite low, but it's a very simple defined question. It's not like training on the chip, but it's not true AI or even a smart system. It's just a system that has been trained to answer a given restricted question. And then think that the edge of the edge, I just said it, for us at the company, we see the fortune of the field moving away from large and costly platform like the phone toward coffee machine, remote control, because all these smart sensor array will help us to make us more efficient. Actually, there is a consumer side, but there's also an engineering of society sides where society needs smart sensor. We need to have better power grid. We need to have quality control of the water system. So essentially, this will, I think, be the true power of AI at the edge of the edge. Now, this is a point I want to iterate for you, because I started my presentation telling you there are many reasons to go at the edge, and we all share that drive. But there is something else. It's privacy. And this is not just a fancy of mine. You know that whenever you go back and forth between the cloud, not with data from your car, for example, that's not the point. Personally identified data. And when humans walk across the IoT seamlessly, there will be more and more PII data. When they go back and forth to the cloud, you can use them for any bad action you want, from deep fake to breach of identity and cyber theft. But at the end of the day, there is a constituency, and more the market, 90% of the people want their privacy back, that would like to have some kind of definition of what is online privacy, because an online privacy breach may have continuous offline privacy consequence. Just think about, if you stole your fingerprint, it's not like your credit card being stolen. The breach is forever, because there is no way you can get a new set of finger. So think about that. So there are issues in Europe that are being addressed with the global data protection rules, the GDPR, and California has also some action, and other states in the US. But we need to use the edge and have AI staying resident on device as a way also to see that we give like privacy right to user, which is not only the right thing to do, but it's a winnable argument. It's a good market position to be in, especially now these days. So what will be, for example, type of product we can make? I mentioned static pre-trained model that could work on chipset or, like microcontroller worth a few cents. Proof of age system, parental control, bot detection liveliness. If I can, with my company, recognize two brain being different and authenticate people based on that, it's easy for us to recognize a non-human actor from human by refining the math and doing something else. And you know that this decreases friction, but these days when 50% of the internet bandwidth is gobbled up by bot and non-human actor, that might have value, and also that's the right way to go. And then ethical metadata. You know, if by having system with some intelligence at the edge of the edge, well, you don't need to profile people to know that maybe it's a female that's young and not an old geezer like me that's handling the phone. And you don't need to know it's Julia versus Martin. And this changed also the consumer engagement, that people will be accepted. This monitoring that's more benign will be accepted better by the market. Then you can also train with classification software and full AI training on the edge, but that is more of a price equation. You need the CPU to do that, etc. And then the list is obvious. We can authenticate and encrypt. We can monitor system. We can look at distributed and monitoring of complex architecture and infrastructure. And at the end, the vision is that you, me, everyone should be able to move across an ecosystem without having to think about it. Because if we have enough smart system around us, whether they're used for authentication or for payment or whatever, in the end, I don't have to remember any password. I don't have to things get done for me, but I have to be in control. So that's a kind of a vision that we have for the future. We're based in California for the people attending from abroad, and we have big plan. We even have a planet.